Hi, everyone. Welcome to the Google Earth Engine demo, a part of Alliance for Peacebuilding and Data Science for Sustainable Development's introductory workshop on GIS for peacebuilding. So quickly, I'm going to go over Google Earth Engine, what the software does, what it entails, the type of analyses you can run on it, and then we will transition into the demo and how to use it for peacebuilding efforts. So Google Earth Engine is meant for the computational geographer. It's a planetary scale platform that hosts a really extensive catalog of open source geospatial datasets and satellite imagery. Some of you are probably familiar with Google Earth, which allows you to explore the world on a virtual globe, but Google Earth Engine provides an API for actually analyzing geospatial data. The Earth Engine API is easily accessible, it's a web-based platform, and it's a means of both visualizing and analyzing data hosted either in the Earth Engine catalog or imported separately from a file. So Google Earth Engine is most commonly connected to through the JavaScript or Python APIs. This demo will look at the JavaScript API in particular, but proper use of it usually requires some programming knowledge or background. Several JavaScript guides are available to help users learn how to program in JavaScript and then use the Earth Engine code editor. One of them is seen here. When I started using this particular program, I only had a few months of Python under my belt and a bit of GIS knowledge, and going through the tutorials actually really helped me to learn how to use Google Earth Engine. But more complex geospatial analyses are best done by users with a coding background and understanding some of the terminology and functions of it. So, and a lot of us at DSSD are pretty familiar with Google Earth Engine, and we use it in a lot of our projects. But this demo won't be a code walkthrough, but rather of an explanation of how GE can be harnessed for your analyses and to use with your data. And again, we're going to use the ACLED dataset that was used in the QGIS and ArcGIS Online demos, and we'll recreate an analysis that I'll show you in a minute. First, I was going to just familiarize you with the Google Earth Engine data catalog. It can pull a lot of different climate variables or anything related to surface temperature, atmospheric data, weather data. It also is great for pulling in Landsat data, other satellite imagery collections in bulk, and doing large scale analyses across just loads and loads of satellite images. It also can pull geophysical data and other demographic data. Nighttime lights is seen here. So fantastic for pulling just huge amounts of data without that extra downloading that you have to do on your computer and pulling in. It already has it really hosted in here for you. But as I said, today we're going to pull in ACLED data that was downloaded from the ACLED website. And we're going to try and recreate some of the things shown in this study. So I found this on social media, actually ACLED's Twitter. And this was a study done recently about mapping Nigeria's kidnapping crisis. And I think this is a huge, wonderful analysis, and it shows a lot. And we're going to try and harness Google Earth Engine's computational power to recreate parts of it, especially the stacked bar chart on the right here. And abductions and forced disappearance events is a sub-event type that each event is coded as. So that's going to be important later on. I also wanted to draw your attention to these 6 groups of perpetrators because we're going to be using those 6 groups already classified by ACLED. And then we're also going to look at this map in a similar function on Google Earth Engine. But this is really important data and really quite critical insights to show. So we're going to see how Google Earth Engine can help us do that. So this is the Google Earth Engine interface, and I'm going to point you to a few really important things on this interface. So on this left panel, you can see all of the scripts. These are all of the scripts that I've ever written on Google Earth Engine. You can also look at documentation as you write your code and how each function really operates, how you can write it appropriately, and then also assets. So I downloaded the data from ACLED and imported it as a shape file. This is how you're going to pull and visualize this data. I visualized it in this, I imported it in this line of code, and I visualized it here. And then this console on the left, you can use the inspector and look at a specific coordinate and any data related there. You can use the console to print out anything that you write in your script and run here. And then you can also import data and through the tasks. But back to the map and what you are seeing right now. So all of this ACLED data is displayed in red, every single event a part of the data set. And we're going to apply two filters to limit the data and the visual view of it. So we're going to limit it to Nigeria, and then only events related to abductions and forced disappearances, which is of course a sub-event type. So that's what we did similarly in ArcGIS Online, but here in a few lines of code, you can just filter this data, apply a filter here. And then all of the events in red are, of course, those in Nigeria associated with abductions and forced disappearance events. So how do we separate out this by year? What I did is I performed a histogram calculation with the filtered data to get the number of events per year and displayed that in a histogram. So as you can see from the listed out results, there was a huge spike between 2019 and 2020, and I looked at that further in this histogram. So the great thing about Google Earth Engine is that every table and visualization that you print in this console is going to be responsive. So I click on this and I see the number of events that happened in 2020, which is 210. And then I can also add a benefit of a Google Earth Engine. You can download this histogram, one that you can add a title to. You can look at the axes and change how those look. You can download them as a CSV, as SVG, or if you want exactly this, a PNG. So different ways to export this data and really access it out of the Google Earth Engine platform, and then analyze it on other platforms. So a few things about this histogram and what it's showing. This chart displays a huge spike in abductions and forced disappearance events in the year 2020. It more than doubled between 2019 and 2020. So in and of itself, this is just a huge data insight. But how do we contextualize this further, get even more from this? So as per the study, let's look at perpetrators associated with this spike and try to separate it out in a bar chart. So we're going to be in the data, actor one is associated with, is how you find the actor associated with each event. So that is the attribute that we'll be using. So from 2018 to 2021, you can print out the number of events attributed to 21 unique groups and actors within Nigeria. And the bulk of those events are associated with unidentified armed groups in Nigeria. There's also a lot with different communal militias. And then as per the study, we can group these 21 actors into those 6 more specific categories. And so a bit of JavaScript knowledge was needed to group those. That wasn't something that necessarily you needed GE for. But what I was able to do was group each. This is my 2018 feature. So this is group 1 and all of the events associated with it, group 2. And then I did that all the way to group 6. I did that for each year. And I put them all into one, each feature into something called a feature collection, which is just a group of those different years. So here's 2018, 2019, 2020, 2021. Again, this is abduction and forced disappearance events by year separated into the 6 groups. And then in a similar manner to how I created this histogram, I was able to create a stacked bar chart. And that's shown here. So this is even more interesting than the one showed before. It showed the rise in abduction events per year, but then it also shows which actor was responsible and for how many events they were responsible for each year. And this already reveals a lot more than what the previous one showed and what other, you know, analyses could show. So for example, state forces were responsible for 62, a huge bulk of the events in 2019, but they kind of weren't present in 2020. And that could be confirmed by other news sources, or that could draw, a lot of questions. But all in all, this is just a more meaningful bar chart. It's a visualization that took only a couple of lines of code to create in Google Earth Engine, but let's also look at this from a spatial perspective, because a lot of these analyses aren't inherent. It is inherently spatial because all of this is geocoded, but for this type of data, let's look at how it is on a map. Right now, all of the points are just red, but how do we separate that out by the different groups and show their abductions and forced disappearance events from 2018 to 2021? So in a couple more lines of code, I was able to analyze each category separately. So taking away this red, each one was colored by its specific color as shown in this legend that's been printed in the console. You can see that unidentified armed groups really were present in the south and sort of in the middle of the country, central Nigeria. Communal militias were seen sort of in this northern region here, northeast, a lot of Islamic State and Boko Haram presence. So this map is showing, a very specific spatial trends for how these abduction and forced disappearance events happen per perpetrator. Again, you can just limit to unidentified groups and really just really filter however you want. And the map is a really great thing for if you want to code something and create a polygon in your script, but then you want it to look one way and then it looks a very different way when you visualize it on the map. Your code is wrong, so you can really validate what you're doing in this script. Uh, Either print it out here or put it on this map and kind of confirm what you're doing.